was discovered by a scientist by the name Masont. So it was discovered by a scientist known as the Masont. These are scientists who came up with that, with this flow graph. So as I've indicated here, signal flow graph is used. It is used to help to reduce the complicated block diagrams. The main purpose is to come up with the overall gain of the system. So at times you can get the complicated block diagrams, which may at times so tedious or so hard to reduce them based on the formulas that we are just seen. So another way of coming up with a way or to develop to come up with an overall gain is by the use of signal flow graph. So what we are supposed to do is that we are supposed to convert the block diagram into the signal flow graph. And in this lesson, we are going to see how we are supposed to convert that into the signal flow graph. So what are we supposed to do, or what are we supposed to consider to come up with a signal flow graph? So one, for us to come up with that signal flow graph, we are going to see things that we need to consider is one, the nodes. So node will help us to identify the points. And number two, we are also supposed to consider the summing points. And then lastly, of course, is the directions. So those three will guide us to come up with a signal flow graph. So what are these nodes? Nodes are these ones. For example, when a node is like this one, that is a node. Here is also another node. The summing point is this one. This is a summing point. This is a summing point. This is a summing point. And this is also another summing point. Then what are the directions we are talking about? The direction is going that way. There is also this one is also coming, forming a feedback. This one is also forming another feedback. So how do we tell that it is a feedback? Because of the arrow. So this one form the forward part. This one form the feedback loop. So let's see now what we are supposed to do. So as we have said, we look at the nodes, we look at the summing points, and of course the directions. So let's come up with a signal flow graph. So our question here is to convert block diagram to SFG, which is a signal flow graph. Convert this block diagram to SFG, signal flow graph. So what are we supposed to start from? We're going to start from here. We call it 1. Then after here we call it 2. And then from here to here we call it 3. And then from here to this one to the next one is 4. And then from 4 to another takeoff point is 5. And then 5 to the summing point gives us 6. From 6 it takes us to that point, number 7. So we have this the input, we have the summing point, we have another summing point here, we have another one here, number 4, the summing point, we have the takeoff point, and then we have the summing point, we have the summing point, and then the takeoff point, and then this one will give us point number 8. So we've got, based on our block diagram, then we can come up with 8 nodes. 8 nodes. So let's count them. So this is 1, 2, 3, 4, 5, 6, 7, 8. Then we can label them. This is 1, 2, 3, 4, 5, 6, 7, and 8. So we now draw the signal flow graph based on the directions of the flow of the block diagram. So we start from R. So from R from 1 to 2, the gain there is just 1. So it is going in that direction, and the gain is 1. And then from 2 to this one, to number 3, here we have the gain to be 1, 1, and then 3 to 4, there is a gain of G1. So 3 to 4, the gain is G1. And then 4 to 5, there is a gain of G2. The gain is G2. And then from 5 to 6, 5 to 6, the gain is G3. And then 6 to 7, the gain is 1. The gain is 1. And then lastly, 7 to 8, obviously the gain is going to be 1. So that one forms the forward bud. That one forms the forward bud. So the node 1 here, we have only the gain to be 1, and then 2, from 2 to 3, the gain is 1. From 3 to 4, the gain is G1, and 4 to 5, the gain is G2, and 5 to 6, the gain is G3, and 6 to 7, the gain is 1, as you are seeing from that block diagram, and then 7 to 8, the gain is 1. That's all. The step number 2 is now to come to the others, which the feedback. We come to the feedback. So we can start from here. So 4, we have from 7 to 4. So this one is coming from 7 to 4. So 7 to 4 is coming that way. It is coming from 7 to 4. From 7 to 4, and the gain of that system is H2. And then from 5 to 3, it is coming from 5 to 3. So 5 to 3, 5 to 3, and the gain is this one should be the gain. We get it from here. It is negative, so the gain is negative H2. Same case with this one. It's coming from 0.5 to here, 3, and you see the starting point there is negative. So the gain will be negative H1. And from there we had convert a block diagram to a signal flow graph. So what remains is to determine the overall transfer functions. Overall gain. What remains is the overall gain, and the overall gain is given by the Mason rule.
I'm offline, so I can't do that. In the meantime, you can get directions, make calls and play music.
So the Mason rule is given by this formula, 1 all over d, the summation of k, pk all over delta k. That is the formula, the Mason rule, delta all over 1 over delta summations of k, that is a p, pk, and then delta k. In the next lessons we shall define what are all these deltas, summations, the gain, all that in the next class. But this rule will help us to come up with the overall transfer functions of that system. So another example as we finish is a time when we are given something like this, then we are told draw when we are given simultaneous. Simultaneous equation. Now, for example, x2 equals to a21 x1 plus a23 x3 equals to a31 x1 plus a32 x2 plus a33 x3. Lastly, x4 equals to a4 2x2 plus a43 x3. Then you are told to determine to draw the signal flow graph. So at times you can be given an equation like this, then you are told to come up with a signal flow graph. So come up with a signal flow graph. SFG. So what do we do? So the procedure is we are supposed to determine the number of nodes. So from the first equation we are seeing x1, and then there is x2, there is also x3, there is also x4. So out of that we have 4 nodes. We have 4 nodes. So 1, 2, 3, 4. We can label them. We can have this to be x1, this one to be x2, this one to be x3, and then this one to be x4. So we can look at the first equation. The first equation tells us x2 is given by a21 x1. So from here we know x2 is coming from x1. So this one is coming from the x1 with the gain of a21. Now a23 x3, it means this one is not going to go in the forward part because it is the arrow is coming from x3 going to x2. So this one will go like this, and the gain will be a23. Then in this equation we are told x3 is coming from this one, and so x3 is coming from a31 x1 plus a32 x2. then we can start from this one. We start from this one. So it means this one is coming from x1. So x1 to x1 to x3, and this one is going in the directions, and again it will be a31, then x3 again is coming from x3 to x2. That means it is going in this direction. So x2 is this one going to 3 like that, and again is going to be a32, then plus a33x. It means it is in the same, it is the same loop, so it's going this way, and this one the gain is a33. Then you go to this one, it means it's coming from a4 to a2, so it is from here going to 4, so it is going to 4. So direction is very important here. This, so x4 is going to x4, and again is a42, and then this one is a43 x3. It means this is from now here going to x4, and the gain is a43, and from there we are come up with the signal flow graph of a simultaneous equations. So what is very important here is to identify the number of loops. Secondly, is also to be careful when it comes to the directions of the flow of these arrows. So we should also note it is moving from which point, or from which anode to which anode. So this is what we call a self loop. This one is called a self loop. It's a self loop. So the next lesson we shall look at how to determine the transfer function of this system using the Mason formula. Using the Mason rule or formula. So how do we determine the transfer functions? Of this, it will help us. The Mason rule or the Mason formula will help us. After that we can say thank you and goodbye.